Hi there, Mr. Sutton here, bringing you the IM312 Part 2 solutions on substitution method. For this one, they want us to solve the system of equations here using the substitution method. This method requires us to have a variable completely isolated, and if we look in this second equation, they've already actually done that for us. We have x all by itself, so now wherever I see an x, I can replace it with 3y plus 14. Now that's going to be helpful over in this first equation where we have both x's and y's. I would like to replace this x right here with 3y plus 14. I mean, I wouldn't really like to do it, but it's going to help me because then I'll only have y's in this equation and I can actually solve it. So I can rewrite this as negative 5y plus 6 times, now we have to make that substitution, parentheses 3y plus 14. All of that equals 32. And let's just simplify this and solve the equation now. So distributing that 6, we've got 18y plus, let's see here, that's going to be 84. And then simplifying a little bit further, these y's can combine to give me 13y plus 84 equals 32. Subtracting 84 from both sides, that's going to be 52, negative 52 actually, on the right side. And dividing both sides by 13, that's going to come out to y equals negative 4. Still need to find the value of x. To get that, we'll take this y value of negative 4 and substitute it for the y in the second equation. So we've got x equals 3 times negative 4 plus 14. So that's negative 12 plus 14, which gives us an x value of 2. So my answer then is going to be the point 2 comma negative 4. To solve this system of equations using the substitution method, I first need a variable to be all by itself. Now, the way things start out here, that is not the case. I don't have x or y isolated in either of these equations. So I'm going to have to pick one of those variables and get it by itself. Looking at this first equation, it doesn't look like it's really going to be all that easy to get x or y alone. So looking at the second equation, this minus y looks promising. Let me see if I can get y by itself in this second equation. So I'll start by subtracting 2x from both sides. So we have negative y equals 8 minus 2x. So that's my first step there. And then I still need to get a positive y. So let me just multiply everything on this equation by negative 1. So I'll have y equals negative 8 plus 2x. And now wherever I see y, I can replace it with negative 8 plus 2x. That would be helpful over in this first equation. So let me plug in negative 8 plus 2x for the y right here. So this is 5x plus 4 times parentheses, negative 8 plus 2x equals 7. Now we just have to solve for x because we only have x's in this equation. So distributing that 4, we've got negative 32 plus 8x there to go with the 5x. And let's see here, 5x and 8x, that's 13x. Add 32 to the other side, that's 39. And dividing by 13, we get x equals 3. Now that I have x, I can replace x with 3 to get y in this equation over here. So we have negative 8 plus 2 times 3. So that's negative 8 plus 6, which comes out to negative 2 for that y value. So then I have the point 3 comma negative 2. To solve this system of equations with substitution, I'm going to find a variable that's already all by itself, and it turns out this y over here is completely by itself. That means wherever I see y, I can now replace it with 2x plus 5. Now that's going to be helpful in this other equation over here. I've already got some x's, I've got a y right here. It'd be nice if I could replace this y with some x's so that I only had one type of variable. So I'm going to take 2x plus 5 and plug it in for this y right here. So that means I can rewrite this as 7x minus 4 times, and now I need a parentheses for my 2x plus 5. All of that equals negative 17. And now whatever was happening to y is now happening to 2x plus 5. So namely, it's being multiplied by negative 4. So I can rewrite this if I distribute as 7x minus 8x minus 20. All of that equals negative 17. Combining like terms, I've got negative x minus 20 equals negative 17. Adding 20 to the other side, I now have negative x equals positive 3. And then that means that x is going to equal negative 3. All right, now I can find y by just replacing x with negative 3 in one of the equations I started with. How about this equation right here that already has y by itself? So I'm going to replace the x here with negative 3, writing y equals 2 times negative 3 plus 5. So that's going to be negative 6 plus 5, which comes out to negative 1. So then my final answer is going to be the point negative 3, comma, negative 1. For this problem, I'm trying to find the solution to this system of equations using the substitution method. So that means I'm going to have to isolate one of the variables and then replace that variable in the other equation with whatever the variable equals. So I don't have anything by itself to start off with, but this y right here in this first equation looks like it would be the easiest thing to get all by itself. So for my first step, I'm going to, in this first equation here, subtract 7x from both sides. And I'm just doing this so that I can get y completely by itself. So we've got y equals 43 minus 7x, or negative 7x plus 43, either of those. And I could have tried getting x by itself, but y is going to be a whole lot easier because all I really had to do was subtract that 7x. Now that I have y equaling all this stuff, I can replace y with 43 minus 7x over in this second equation. So that's going to be my second step to make that substitution. So I'm going to write 12x minus 6 times parentheses 43 minus 7x. All of that equals 12. And now I only have x's over here, so I can solve. Well, I'm going to have to distribute in this parentheses. So I know that negative 6 times negative 7x is going to be 42x, positive. But how about 6 times 43? Well, let's see here. 6 times 40 would be 240. 6 times 3 is 18. 240 plus 18 would be 258. So this is negative 258 plus 42x. And feel free to use the calculator on that. Combining like terms now, I can write, let's see here, 12x plus 42x gives me 54x on the left side, along with that negative 258. Now let's get that 258 over to the right side by adding it. So that's going to give me 270 on the right side. And what's 270 divided by 54? Well, I'm not really sure, so let me go to the calculator. So 270 divided by 54 comes out, oh, that's nice, just 5. All right, so we have x equals 5. I still need to find y, though. We did a lot of work to find x, but we're not quite finished yet. So I'm going to plug in 5 for x. Over in this equation here looks like a good one because I've already got y by itself, but I could have really used any of these equations up here. So let me do y equals, and then we're plugging 5 in for x here, so 43 minus 7 times 5. So that's 43 minus 35, which gives me a y value of 8. So my final answer then is going to be the point 5, comma 8. On this problem, I'm trying to solve using the substitution method, so I need to get an x and a y value that solves this system of equations. So to start this off with substitution method, we like to have a variable completely isolated by itself. Looking at all my variables here, it doesn't look like x or y is going to be easy to get by itself in the first equation, but in the second equation, y is already almost by itself. So all I really have to do to get y by itself in the second equation, it's actually going to be a two-step process. I have to subtract 7 from both sides to get y, or at least negative y by itself. But I don't want negative y, I want positive y so that I can just directly replace y with whatever the other side of the equation equals. So I'm going to multiply or divide this whole equation by negative 1. So that gives me negative 2x plus 7 equals positive y. Now I have positive y expressed in terms of x. So at this point, I'm going to replace the y over in the first equation with that negative 2x plus 7 expression. So I'm going to write 6x plus 5, and now I need a parentheses, negative 2x plus 7. All of that equals 21. Distributing now, we've got, let's see, 6x minus 10x plus 35 equals 21. Combining like terms, that's going to be negative 4x plus 35 equals 21. And then I can subtract that 35 to the other side. So that's going to give me, let's see, negative 14. Now to solve for x, I have to divide by -4. So that's going to be -14 over -4, which I can reduce by 2's to give me a positive 7 over 2. Now you might be doing a double take because you're probably used to getting nice whole number answers on these questions, but fractions are also allowed. You know, let's just go where the math leads us, right? So we have an x value of 7 over 2. We still need to find the y value. So I need to plug 7 over 2 in for x in an equation that also has y in it. Well, how about this equation over here where we basically just got y by itself? So let's replace this x with 7 over 2. So we can write -2 times 7 over 2 plus 7 equals y. And fractions aren't a ton of fun to multiply by, but the key on this is you're basically dividing by the denominator and multiplying by the numerator. So -2 divided by 2 would give me -1, times 7 would give me -7, and we still have that plus 7 there as well. And -7 plus 7, well, that's not so bad, that's just 0. So our final answer is the point 7/2, 0.